Hey, Vlad here, devinsidey.com, and welcome to the next video in the Scala playlist. Today we're going to talk about higher order functions, and even though there's nothing special about them, they open the door to an entire new world of incredible benefits. In this video, I will simply introduce you to the concept with a few examples, and we might even discuss a few technicalities that surround the topic. But only in the next video, you're going to see arguably the most important benefit that you get from them. You will learn about one of the most fundamental techniques in software craftsmanship. You will learn how to harness the power of inversion of control, which is impossible without higher order functions. As always, we're in the virtual machine which runs Ubuntu, and we have Sublime this time at the top and the terminal at the bottom which runs our code. This time, before jumping straight into code, let me say a few things. This playlist is called Scala, your first programming language, for two reasons. Firstly, the actual name doesn't really fit into a YouTube thumbnail, and secondly, I assume that Scala is the first programming language that you get to learn. I'm repeating this because the topic that we're discussing today can be mind-bending for people who are accustomed to other programming languages, specifically languages that don't support the so-called functional programming style very well. Also, remember in the video about subroutines, we played with functional literals. Well, the thing is that even functional literals are not present in every language. If you learn about them later, then usually they're introduced to something special, some extra feature from some other world. The word paradigm also gets thrown around a lot. However, if this playlist is really your first exposure to programming, then I hope that the way I explained functional literals didn't even make you think twice about them. The same way you can use an integer literal to create an integer object out of thin air, exactly the same way you can use a function literal to create a function object out of thin air. The same way you can bind an integer object to a variable called favorite number, exactly the same way you can bind a function object to a variable called favorite function. The same way you can pass an integer object to a function called show, exactly the same way you can pass a function object to yet another function called show. You get the idea. The last example gives you a taste of what higher order functions really are. Whereas a regular function accepts and produces instances of irregular types like integers, booleans, or strings, a higher order function accepts or produces other functions. In this video, we will talk only about the first part, functions that accept other functions as their arguments. And a few videos later, we're going to talk about functions that produce other functions as their result. By the way, the last few minutes in the previous video already talked about this topic, even though I didn't mention it explicitly. I didn't call them higher order functions. Remember this method called left to right that would accept the left function and the right function and produce yet another function? That was a higher order function. Or remember when we were saying 1 to 10 for each print line? Well, for each was a higher order function that accepts print line as its argument. Enough talking. Let's write some code. The first thing that we're going to do today doesn't have anything to do with higher order functions. I'm sort of tired of having this scope here just to have those hyphens. So what we're going to do over here, so instead of having all of this, we're just going to call a function called code, and we're going to pass in the arguments. And over there, we're just going to define this function, which is going to look exactly like the main function. Right? Turns a unit, whoops, unit equals, and it will, in this case, just do print line hello world, right? So the result should be the same, but now it allows me to just collapse the main function, and all our code is just going to be over here. Let's start with something simple. Let's define a method called +5. It will take some input, which is an integer, and it will produce an integer, right? And all it will do is it will do input +5. Not sure why it's so hard to find the plus character. All right, so we have this function, and what I want to do here is I want to have a rendered +5, which is going to be a string, right? And I just want to print out whatever is going to be there. Okay, so what I want to have here is just a string, right? So I wanted to say function, and the name of the function is +5. Right? And I want to say that the argument is, let's say 10, right? And the actual result is, well, 10 plus 5 is 15. So this is what I want to have, right? But notice that in this example, we're not even calling +5, right? So let's first do this, right? And actually, get some sort of like a better highlighting. So if you use string interpolation, right, then we're gonna see our values, right? So we have 10 over there and 15 over there, but we produced this 15 ourselves, right? So in our heads we did 10 plus 5. What we actually want is we want to call plus 5 with 10, right? So we're gonna have plus 5 with a 10. And the result is the same. So what I want to have now is I want to have another function of exactly the same kind. So I want to have another function that takes an int and produces an int. This function is just going to take the input and divide it by 2, okay? And I'm just going to copy paste everything. So we're going to have everything twice, right? And everywhere where we say plus 5, it's going to say, we're going to say divided by 2, okay? And this is not going to be a render plus 5. This is going to be a rendered divided by 2, okay? And the argument is going to be 20, and it will actually divide it by 2, okay? So this is what I want to have. So for a plus 5, we give it a 10. 10 plus 5 is 15. For divided by 2, we give it a 20. 20 divided by 2 is 10, okay? And I sort of want to make it look like a table, and therefore we're gonna, instead of a space over here, we're gonna use a tab character, and we're gonna do the same thing over here, right? And because of that, we're gonna do the same things down there and over there. Whoops, over there as well. Okay, so if we render it now, it's gonna look more like a table. Let me now rearrange the code a little bit. And by the way, this is already a in 11's video, I think, in this video, in this playlist. So by now you should know that programmers don't like repetition, okay? So now you can kind of see all code in the same screen, and you can see the repetition a little bit better. So what we want to have now is we want to have a function rendered that will get a few arguments, and it will produce this sort of string for us, okay? So let's define it over here. By the way, so as of right now, I hope I didn't break anything. Yes, I did. Okay, so we're going to have a function called rendered. It's going to take a few arguments, and then it's going to produce the string for us, okay? So what it will do is it will actually, let me duplicate that. Okay, let me put it over here. So it will take the function name, right? Function name, which is a string, and it will use it over here, right? So this is going to be function name. Then it will take the argument, which is an integer, okay, and it will just use it over here. And because it's one thing, we don't need the curly brace, okay. And it also is going to take the result, right, and it will use the result over here, okay. So let me see if that compiles. So we're not calling rendered yet, but at least now it already compiles. So now let's take this one, right, let's just copy paste it over here. Let's call this one old, okay. So now this one is called, okay? So now we're just going to replace this with the call to rendered. So we're just going to call rendered, and the function name is going to be +5, okay? And the argument is going to be 10, and the result is going to be +5 with a 10. And now because what we're seeing over here is the same, we know that we did it right, so we can remove the old one, okay, and we can also remove the we can also replace this one, okay. So let me just duplicate that. So this is now divided by 2, and a 10 becomes a 20, and this also becomes divided by 2, okay. So we can remove the manual string. Let's also real quick remove the named parameters. So let me see, maybe I can do this and that, all right, and the same thing over here, this and that, and now we can have them in one line like this. And let me indent it a bit like that, so that we see it better, okay. So this is what we have now. Now, the thing is that, first of all, this is already really good, but we still have duplication, right? So first of all, this thing, it sort of looks like duplication, but it's actually not, whereas this one actually is duplication. So this is not duplicated because actually we're going to call this function, for example, +5, right? And this one is divided by 2, okay? So now we can do this, right? So now it should be more clear that this is actually not duplicated. This is more like a coincidence, okay? But this 10 is actually duplicated, and this is where we're going to start using higher order functions and see their value. So in this example, we're going to use higher order functions to get rid of some duplication, right? So our code is going to be more concise, but do not fool yourself. This is not the only benefit of higher order functions. The list of benefits just goes on and on. It's just that I picked this example because I think it's a really good one for education purposes. Okay, so in this case, higher order functions are going to help us to get rid of duplication. So our rendered function is actually a lower order rendered, right? So there's I'm not really sure if there is such a thing as a lower order function, right? But I thought if there is this thing like a higher order function, probably, you know, the function that does not take any functions as arguments should be called lower order rendered, right? So okay, so this one is called lower order rendered. So let's create a higher order rendered. So I'm just going to duplicate the signature, right? And I'm just going to call it higher order rendered. Higher order rendered. So I'm not going to make a higher order function out of it yet. I just want to keep it compiling, right? So I'm just going to call lower order rendered with function name, argument, and the result. So as of right now, over here we're calling lower order rendered, but now I want to call higher order rendered, right? And the result should be the same because this function, as of right now, it just delegates to this one, okay? But this is not what we want. So what we want is, let me remove the last parameter. What we want is, let me use a name parameter over here. So what we want is, we want to have something different here and something different over here. Higher order functions accept other functions as arguments, okay? So let's give it one. So let's say that this third argument is actually a function. In this case, a function that takes an integer and produces an integer, okay? And the result is just going to be this function which gets this argument passed in. So we're just applying this argument to this function. And because of that, when we call higher order rendered, the last argument is now not an integer, right? So if we compile it now, it's going to tell us, hey, we found an integer, but we actually want a function that takes an integer and produces an integer. Well, plus 5 and divided by 2 are those functions, right? So all we need to do is we need to remove the parameters. Right, we need to remove the argument, and this is what we wanted to do, right? From the beginning, we wanted to get rid of this duplication, right? So now higher order rendered will call this function for us, right? So it will call plus 5, and then it will call divided by 2, and it will produce exactly the same result. And before we continue, let's clean this up a lot. So because it gets smaller and smaller and smaller, let's just not have those extra vowels. Let me just inline those two, so now we can remove them, and then we can actually see most of the code on one screen. And also, let's define a function show, which will do println and higher order rendered at the same time. So we're just gonna duplicate this one, right? And we're just gonna call it show, right? And all it will do is it will do println, and then it will just call higher order rendered for us, and we'll just pass everything. Sorry, function name, argument, function to it. Okay, so we're just going to use show over here, and now we don't need the closing brace, and now we don't need the print line. Okay, so the show is doing the print line for us. Okay, it's exactly the same code, and what I did wrong, oh yeah, because I duplicated it, it has to return a unit. Okay, because it's just doing a print line. Okay, so this is exactly the same code, just rearranged a little bit. Also, since we're in Scala and Scala has function literals, look at these two functions. They're actually really tiny. We don't need extra definitions for them. So we can just do this. Whatever comes in, 2 plus 5, and over here, whatever comes in, 2 divided by 2. Okay, and let's do this now, and it should be exactly the same. Oops, there's a space over there. Yeah, so it should be exactly the same, and now we don't even need these, right? I already said this in the very beginning, but really know the difference between functional literals and functions as object, because most languages actually have functions as object in one way or the other. Maybe they're sometimes hidden behind stronger syntax constructs, but not all languages have functional literals. So only because your language doesn't have functional literals does not mean that it cannot have higher order functions in one way or the other. And by the way, remember Scala has this awesome syntax where we can just say whatever comes in, do plus 5 or do divided by 2, right? So look at this line, it's just so tiny now, and our code is just a few lines long, and it's doing virtually the same thing as it was doing before. Let's have a few more examples. Let's have a, let's have times 3, for example, and let's give it a 2 as an argument. So let's also do mod. Let's do mod 2, right? The argument is going to be, I don't know, let's say 9, and it's going to do mod 2, okay? And so yes, 9 modulo 2 is 1. Let's do the same one with a 10 actually, right? And now because we have some duplication, actually hold up, let me do that and that and that. All right, so now it sort of looks like a table. So now we have a little bit of duplication over here, right? And now you have a choice, right? So you can either have a function mod here, right? You can have it as a function that takes an int and produces an int, right? And then you can just take this and paste it over here, and now over here you can just use mod, right? So you can either do this, or you can use the other syntax, right? Let's comment this out. You can use the method syntax, right? So you say whatever comes in, right? And integer comes out. We're just going to do input modulo 2. Okay, and notice that even if we do even if you use one character, and I'm not sure if this is a coincidence or not. So let's just use an x over here instead of input. Let me uncomment that. Look, this one is still shorter, right? It's kind of funny. Also, let me do this that you may be you might not be used to those kind of things. Let me do that and over that so that it sort of looks kind of similar, but we can't have both of them, right? We have to decide. So are we doing this one and let the add expansion to convert it into a function, or let's just give it a function directly and have that, okay? Remember in the video about recursion, we defined functions factorial and Fibonacci, and they just happen to have the same structure, right? And some integer comes in and some integer comes out. So let me just copy paste them from this video, and I'm just going to insert them somewhere at the top, somewhere I don't know, over here. Let's have them over here. Right, so you don't need to understand the implementation, just rewatch that other video. In fact, I'm just going to collapse them. The only thing that is important to us is that the integer comes in and the integer comes out, right? So what we can do now, assuming that it compiles, and yes, it compiles, what we can do now is let's have an empty line over here. Let's have a print line. Okay, so the first one is going to be a factorial, and the argument is going to be 0, and it should just call factorial, okay? And let's do it a few times with a 1 and with a 2, and we should see. All right, obviously I didn't want to call print line, I want to call show. Whoops, sorry, show. There we go. Okay, so factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2. That's not very spectacular. So in fact, we want more numbers. So what we should do now is we should define another function that can not take only one argument but multiple arguments, right? So over here, show takes a function name. It takes one argument and then it applies this one argument to this function, right? Even just once. Okay. So what we should do is we should define our own function, yet another one, and we should call it show range, right? So it will take the function name, but then it will take a bunch of arguments, right? A whole range of arguments, okay? And the function, and then it will just go through this range, right? We'll just say arguments for each, okay? And over here we have the argument, and we're just going to show function name, argument, and function. And by the way, notice for each itself is also a higher order function, right? So it takes another function as its argument. Okay, so this should compile now. Yeah, so this compiles. So let's go here now, right? So instead of doing this nonsense, let's say show range, right? And let's say factorial, and the range is going to be 0 to 10, right? Factorial, and let's remove this. Okay, and if I did everything right, then we see factorial from 0 to 10. Okay, seems fine, right? Yes, factorial of 5 is 120. I remember that one. All right, and let's do the same thing for Fibonacci. Show range, Fibonacci. There we go. 0 to 10, Fibonacci. I remember the 7th one is a 13, the 8th one is 21, and so on. Yeah, it's all good. Now, these examples might not have been the best ones to show you the value that the higher order functions provide, but I believe it was a good way to show you how to drive your design towards higher order functions, and also to see how they actually work. As I already mentioned, high-order functions play a very important role in modern-day programming. They're present in virtually every programming language, even though most languages don't have functional literals. It is very common for high-order functions to be wrapped around in some very advanced syntax constructs, right? Syntactical constructs that we're going to discuss in the future. Maybe if you're familiar with object-oriented programming, for example, they're usually hidden behind interfaces and classes, right? So you don't really see them. But in Scala, they are so-called first-class citizens, and the first-class citizen is a term that basically means that you can use them as any other data. You can pass them around, you can bind them to variables and so on. Just to show you a little bit more what it actually means to use high-order functions. Usually, you would have some sort of algorithm, right? For example, for each, right? It knows how to go through this range of arguments, right? But it's not an entire algorithm, right? It's a partial algorithm. A part of it is missing, and this part just happens to be another algorithm, right? Sometimes it's tiny, sometimes it's huge, right? For example, Fibonacci is a relatively big algorithm. In case you're someone who is familiar with object-oriented programming and all the patterns that come with it, then in Scala and all other languages that have functions as first-class citizen and maybe even functional literals on top of them, then they allow you to implement those object-oriented patterns in a way which basically reduces your code to the bare minimum. So you can implement these patterns with minimal verbosity, like for example over here, right? This is very, very minimal. Okay, now we're actually by the end of this video, and finally I made a relatively short video. Before I leave, I'm going to show you some very special Scala syntax. I should have mentioned in my very first video that Scala is a very sweet language. It has a lot of syntax sugar. All right, so let me remove everything that we did today, okay? And let me define a function called loop. So what loop will do is it will receive a code argument, right? So loop is going to be a high order function, and it will receive a code function which doesn't take anything, right, and produces a unit, okay? And loop itself will produce a unit, okay? And all it will do is it will just go from 1 to 10, okay, which is a range. And for each iteration, which we don't really care about, right, it's just going to call our code function, okay? So if you call loop, for example, was a function that doesn't take anything and just prints out, my god, what did I just do there? Prints out high, right? It will print out high 10 times, okay? And let's use this syntax over here, right? So remember, if a function receives only one argument, then you can use the round parentheses with curly braces, okay? So let's just have this, and usually when you do this, then you have this part. It's very common to have it like this, right? And you see an example over here, right? It's very similar, okay? So let's call it like this. So there's a very beautiful syntax sugar for that, okay? So let me call this loop old, right? And let me duplicate both of these, both the function and the call of it, right? So let's call this one loop new. Come on, new. There we go. Okay, so as of right now, they still look the same, right? And let me actually have a print line in between them, okay? All right, so we have the first highest and the second highest. And in fact, let me actually do this and that, right? So now we can see the whole code, and now we just need only 50 hyphens. And let me collapse the main again. All right, so now you see both the old version and both the new version, okay? The next thing that I'm gonna do is you can do it almost mechanically, right? So I'm gonna mark these parentheses, right? And I'm going to press Control D, and I'm going to press Control D again. So in these three places, we can just remove them, right? And in the very bottom one, we can also remove the arrow, okay? And let me remove an S space over here, right? So these both pieces of code are equivalent. So whenever you have a high order function that receives another function as its argument that does not receive anything, right? So the argument that this function that it's being passed to is a unit, right? Then you can use this syntax, right? You can just leave the parentheses out. You just have an arrow, and then the unit, okay? And then when you call it, you also don't use the curly the parentheses, right? And you're doing all of that just so that your clients, right? So that your clients don't have to write this thing. Sorry. That thing, Okay, so the client code looks actually kind of cool. Actually, let me rename loop new to just loop. Look at this code. It looks so beautiful. Just loop print line high. Actually, let me call this a loop 10 because it goes from 0 to 10, right? Loop 10. Loop 10, print line high. Two things you need to know about this. Whenever you don't have an argument like this, you're saying that you're passing an argument by value. And every time you do have this, you're saying that you pass this argument by name. It's just a convention. It's just being called like that. There's nothing special about it, right? It's just syntax, right? So whenever the compiler sees this, it will convert it into that. Okay. The second thing you need to know about this, and we're going to discuss this a bit more, actually in quite a bit of detail in the next video about inversion of control. Notice that every higher order function is in charge now of this tiny function that you pass in, right? So it can decide, for example, not to call it at all, or it can decide to call it twice, right? And if you have syntax like this, then you know that what you're passing in is a function. Over here, if you don't see the definition, right, you don't really see over here that this will be wrapped into a function, right? You don't really see that this will be wrapped into something like this, right? So this is a bit more surprising, and when you gain more programming experience, you will understand that you don't really like that, right? So we don't really like libraries that surprise us, right? It's called the principle of least surprise. So always try to write your function in such a way that they will not surprise your callers, right? So this function, this syntax is less surprising than this one. So apply it gently, be very careful with it. Alright, this is the end of this video, and I'm super glad that I finally made a video that is actually shorter. My recording software shows me 46 minutes, so when I'm going to cut it, it should be like about half an hour. What you should know is that we're nowhere near done with higher order functions. Basically, all the code that we're going to be writing from now on, we'll have them in one way or the other, because they're just really useful, and they're basically used everywhere. Sometimes you don't see them, right? Okay, so I hope you liked this video. Like this if you did, subscribe if you're new here, and see you next time. Take care.